Are you ready to see something that is just a little bit crazy cool?
You're holding a hard drive. Anything specific you'd like to know about it?
Today we're running the latest Qwen3 Omni local, and we're going to see what kind of capabilities it has. This is really a first look also because I just got one thing done just to validate it worked. So I hope you're excited. Let's get started. So we've got the Qwen3 Omni demo up and running locally, and you can see this is using transformers down here. And if you are running this locally, you do need to use transformers if you want to have audio generation. Yes, that's right. I said audio generation. This is an omnimodal support, so it will take video, it will take images, it'll take text, and it can output a variety as well. So we'll keep an eye over here and kind of watch this. It does take a while to load up. Transformers is slower than VLLM, but VLLM is not capable of doing audio output is, I think, if I'm recalling what I read in this. So this is how it works. Let me just show you the workflow really quick. So I'm going to talk to it. Hey, how are you doing today? And hit submit. And if I play this, hey, how are you doing today? You can see that it's got that one little snippet. Come over here, you can see that it's actually processing, and in just a second, we'll get a response back from Qwen3 Omni AI.
I'm doing great, thanks. How about you?
And that is pretty freaking cool. So one of the really cool things, though, is that it is able to do things like read and visually understand an environment. So let's do this again. And can you read the letters on my hat? Let's just see if it can do that. And so here is ours. This again. And can you read the letters on my hat? And Transformers is going to be slower than VLLM. Just keep in mind. Still, we're using the Quad 3090 rig. You can find out a lot of information about that in the channel history, where we do everything from set it up and everything else.
Sure, I can see the letters on your hat. It says DSP.
That's freaking sweet. Okay, let's give it another one here. So, of course, I'm in the midst of my major rack home data center AI redo, and I knew this was coming. This is one of the main reasons that I was doing so much work on this, and there's a lot that has to be done to make a really efficient, large amount of storage available at really high speeds, which is what I have to do. I can't test effectively many models without having that capability. And having the old setup that I had, which was geared towards storage just being very large but not very fast, really was not optimum. It did require me to actually change things up. Next, we're going to ask it if it can understand what this is in my hand. Hi, so what is this in my hand that you're seeing right here? That's difficult. That is very difficult. We'll see if it can get it. Oh yeah. So the way that this plays, your chat history is like literally snippets. This is so cool. This is so cool. Hi. So what is this in my hand that you're seeing right here? It does take a lot of time, even with Quad 3090s, to get a response though.
You're holding a hard drive. Anything specific you'd like to know about it?
So I was even moving that hard drive around. Let's see if it can read how big the size of it was. So let me go ahead here really quick. And can you tell me what size the hard drive was? And we'll see if the Gradio interface can keep up here. It looks like it is churning. And so this is truly multimodal AV here. So that brings visual understanding into your local AIs with a really good capability set. Now, this is just the Gradio demo. There's a lot of sample code that they have, so you could adapt this to make kind of a real-time chat interface. It would take some time to do that, but you would be able to do it. So let's see.
Oh, it's a 2.5-inch SAS hard drive. Pretty standard for servers or high-performance systems.
So I don't think it got that. Let me try again here because the interface, Gradio interfaces are kind of known for this. Let me see if I can get this to actually understand. I'm going to ask it, what is the size? And I mean, that's very small, and I was moving it around. So I'm going to try it again and I'll hold it. And I've also got, studio lights. So maybe I can hold it like this and let's see if I can get it to where it can read it a little bit better. Can you tell me what size and what capacity this hard drive is? Okay, there we go. Can you tell me what size and what capacity this hard drive is? It's a 14 terabyte. It is SAS, but it's not 2.5, it's a 3.5. And the 14 terabyte should preclude most 2.5 inch drives from being, well, I don't know. I don't think there was ever a 14 terabyte, 2.5 inch SAS drive. We'll see. We'll see what it comes up with here. And this is in real time. I'm not speeding it up or anything.
It's a 2.5-inch hard drive with a capacity of 14 terabytes.
So it did not get that it's a 3.5 inch hard drive, but it did get the 14 terabytes. So it's able to read what's on the hard drive. And I mean, that is so small right there. And it's slightly out of focus. That's insane. That is crazy. All right, let's ask it about a high performance network card. Now, this is not your standard network card. This is like what you plug into 100 gigabit switches, which I've got, 100 gigabit switches. By the way, insane stuff in this channel's history. If you've never checked it out, definitely go check out this channel's history. So let's see if it can understand that this is a QSFP28, and I'm going to ask it some different questions about it and who makes these. So let's just give it some questions here and see what its understanding is. Now, you definitely want to read its system prompt. So it's not geared to give you long replies, which is great for conversation. It is only looking at about giving you 50 words as a reply. So you can't ask and chain together a really complex amount of information requests to it and have it probably function. But we'll see if it can get this here. So let's go ahead and record. In my hand, I've got a piece of computer equipment. Give me some details about it. Be specific. That's hard. I mean, if I showed this to most people out there, they would not understand what it is. In my hand, I've got a piece of computer equipment. Give me some details about it. Be specific.
You're holding an NVMe SSD expansion card. It's a PCIe add-in card that supports NVMe drives, commonly used in servers or high-performance workstations. So
that is definitely an incorrect answer. However, I'm going to try something else here. And okay, so let me turn the hat backwards real quick so that it can't cheat. Let's see if it can recall from the prior vision examples that it's been given, what the colors were of the letters on my hat. So let's try this out. Earlier you saw my hat. What color were the letters on my hat and what color was my hat? We'll see if it can understand that. I'm asking a lot of it. I am asking a lot of it, but this is where we start to broach into serious consumer applications being capable. This is an amazing release from the Qwen team. Massive, massive kudos. And they're releasing more stuff also. So there'll be more videos, I'm sure, on more Qwen things, and we will be definitely diving deeper into this before too much longer. But yeah, definitely, if you're interested, I will have a written guide on how to get this up and running locally for yourself. It is a few steps. It's not that complex. If you followed along with my prior guides for setting up and running your Proxmox environment, which is a great way to do a local LLM work lab where you can really, really expand upon and get to test out lots of things very flexibly. And yeah, it gave me an error on that one. Okay, so maybe it ran out of context window. Something happened. I'm not sure exactly what, but definitely it did crash out the interface here. Let's see if we can refresh it, and all the chat history is gone. Yeah. So it could also be, I think, let me go to the summary on this. Ooh, 93.96% of hard drive utilized. So that's not good. I don't think that's what it was, but definitely that is not good. So let me hit Control C really quick here. We'll close the server down and then I'll open it back up and start it up again. And we'll take a look at some of the other functions that it has on it. So let's go here and run this web demo. And it will take a little bit of time. The first time you do it, it'll also download everything. And you do need to have a 2-part step installation that's not super clearly outlined. So definitely follow along with the written guide, which is not out yet, but it will be as fast as I can get this out. Time is one of those cool things where you gotta be out there with these kind of things as soon as you can. So I'm going to be out here with this one, and that will be on digitalspaceport.com. After it's loaded up the first time and downloaded, loading the shards in the second time hopefully isn't going to take too long here, probably another minute and we'll be up and running. Whew, this is so cool. This is so cool. I fully expect them to have a 1T model out at some point. That seems like it could be coming down the pipeline. And I've only got a couple systems that'll be able to possibly even touch that, but definitely you might get to see some clustering and distributed inference very soon. So let's see, that was 6 back and forth chats that happened before it crashed out. So there was one that I deleted from earlier, and then there were 5 that I just did right there, I think. So yeah, that kind of makes sense. Okay, interface should be back up. Okay, so offline inference also. So this is not having a real-time chat with it, but you can click on the expand tab down here. It's got upload audio, upload image, and upload video. Some of the really cool features that you get with this new latest model are all of these use cases. I mean, speech recognition, speech translation, music analysis, sound analysis, audio captioning. So if you look at this model also, you're going to note that it's got a captioning variant, it's got a thinking variant, and it's got an instruct variant. The instruct variant incorporates both of the other two. However, it's so new that it may not yet be in there. So that might take a day or two for it to be in there. I'm not sure exactly what the status is. It says that it's in a PR state. So there's a pull request out. When it gets mixed in there, it is going to, be pretty cool. So just in the category of audio, you have all those use cases. In the category of visual, you've got OCR, and we saw it able to read the 14 terabyte hard drive. Object grounding, target detection, and grounding. So I think you would be able to say, I could probably ask it a question about like, where is something in relation to another thing that's in there? And it should be able to probably tell me where that thing is in relation to the other thing. Image question, answering arbitrary questions about any image. Image math, solving complex mathematical projects in images, highlighting the capabilities of the thinking model. So that looks like you would probably be able to write out some hand notes, show it instead of having to write LaTeX or something like that. Probably pretty cool, really rapid for people that are doing that. Video descriptions, detailed description of video content. Pipe in a video, have it give you information back. Video navigation, generate navigation commands from first-person motion videos. That one, I don't even know. That one sounds really cool. Video scene transition, analysis of scene transitions in videos. So I guess you could, probably ask it where things are progressing. I don't know. Audio visual. Audio-visual question, answer arbitrary questions in audio-visual scenarios, demonstrate the model's ability to model temporal alignment between audio and visual. Audio-visual interaction, that was what we were just demonstrating highly. Interactive communication with the model using AV inputs, including task-specific via audio, which I was giving audio commands. Audio-visual dialogue, conversational interaction with the model using audio-visual inputs, showcasing its capabilities in casual chat and assistant-like behavior. Agentic calling, so audio function calling. Hey, I want you to turn on the servers. Boom, servers turn on because I've got, the IPMI capabilities to do that. And if I write an instrumentation piece behind the scenes with an MCP, it should be able to turn on a server. It could be dangerous. You got to be careful with that kind of stuff. But yeah, that's the kind of capabilities. Downstream task fine-tuning, Omni Captioner. This is an introduction and capability demonstration of Qwen3 Omni 30B A3B captioner. All of this is built on that 30B A3B, a downstream fine-tuned model based on the 30B A3B instruct, illustrating the strong generalization ability of the Qwen3 Omni foundation model. So you can fine tune on top of it also. And I think Unsloth has a speed up thing for that also. So you might check there if you're looking for more information on that. I don't have more information on you for that right now. The model description and download, of course, like I mentioned, the instruct is going to house both of the thinker and also the talker. The talker, I guess, is it's complicated. You need a hierarchy tree to understand it a little bit, but the instruct is what houses the biggest amount of capabilities, and it also requires the most VRAM. So with 4 GPUs on this, I'm able to run this and still do pretty decent. There's a lot of commands here, which I'll put together a more concise guide. There's some jumping around that you're going to have to do to get up and running with the Gradio interface that I'll show you. But right here, it gives you some information on the precision at BF16. For running, say, 30 seconds of video, you need 88.52 gigabytes, which that's pretty much going to be the limit of where my GPUs are going to be able to tap into. If I wanted to go with just the thinking and not the instruct, I might be able to get 60 seconds of videos. I'd probably have to use CPU offload, and that may not function. Sometimes CPU offload does, sometimes it does not. Since this is using Flash Attention 2 and kind of an actual little bit older VLLM, it very well might. And this is also one of the reasons that using Proxmox, like I mentioned, using an older VLLM, people are like, why do LXEs? I can't tell you how many times today I went back to snapshots on this one here and messed around, like just so many times. Now, for the demonstration, I'll be creating a new container so that container can be up and running as a dedicated instance, which literally just meant cloning it. Like, it's so fast to do it the way that I've got this set up. So there are reasons to use LXC and Proxmox specifically. People insinuating elsewise don't know what they're talking about. And that is actually a lot of people that are asking the question. Happy to answer that. If you're a Python expert and you can manage really complex environments yourself, go for it. But you start mixing all these things together, it gets complicated. And this is a channel that's geared to be noob friendly. I don't want to talk to advanced people and give them instructional information. That's not the guidance of this channel. So let's go ahead and upload an image here. This one is complicated. Oh my gosh, this is the Visio diagram of my rack layout. This is hard. That is hard. So this is the rack redo, which I am doing. I'm on part 3 of that video series. Part 4 took a break because I wanted to get this video out. I was so excited when I saw this. The Omni model being able to run it locally is so bleeping cool. I mean, they cooked hard. They cooked so hard. Yeah. And if you're just running offline, you might want to run VLLM for visual. I think it can do that. I think it's audio generation specifically is what it cannot do. Let's make sure we're not running out of space over here. You know what? I'm going to give it just a little bit more space. And this is what I'm talking about. I'm having to micromanage size on these things way too much for the Flash. And I need to be able to utilize my platters as a hot and cold setup so that I can have a lot of information stored, a lot more information stored, a lot more models stored, and not have to back and forth with them and juggle it around. So let's see if it got that answer. It's a tough one. It is a tough one. Come over here and hit NV top. Looks like it is thinking on it. And keep in mind also, you're going to need to customize the Gradio template just a little bit to be able to do what I'm doing. And also there is some settings that you need to enable since you'll be using non-HTTPS for your local, unless you're using a like caddy or something like that, reverse proxy, which can add some complexity when you're doing things like video, audio, and image uploads to a web server. So it's probably just easiest to demonstrate in this capacity versus setting up a reverse proxy and having to go through that, because that can be its own rabbit hole right there. Definitely not super fast though. Should show up here, I'm guessing, in the chat history. Very, very complicated. Very complicated if it was able to understand this. I might ask it if it can understand the logos, because I've got a Proxmox logo and I've got a TrueNAS logo in there. And I don't think I've got those explicitly written out in relation to that. So that could be interesting. Still chugging along. Okay, that took a really long time. I would say that was 6 minutes. Now, some of that could have been that it was an initial load, but let's see what it's out. Oh, this is also so cool.
This diagram shows a high-level architecture for a storage and compute infrastructure, likely for a data center or enterprise environment.
Garage data center.
On the left, there are 4 servers labeled as Dell R73XD and Dell R930, acting as Proxmox hosts for virtualization. They have various network interfaces and are connected to different networks like Digital Spaceport, LAN, Storage Network, and NGMT network. On the right, there are 5 storage systems, all NetApp DS4246 and 1 NetApp DE6600, which are connected to the servers. They use iSCSI for storage networking and have different configurations for redundancy and capacity. The system also includes an LTO5 tape library for backup and a power distribution unit, 9PX11K, for power management. The servers and storage systems are connected through a network infrastructure, including switches, to ensure data flow and redundancy.
So it did excellent. That was perfect. That literally is, let me get that image and pull it up here so you can see it like full screen. That is perfect. Yeah. Wow. Yeah. 5 DS4246s, 1 DE6600. And the associations with these are over here. So there's not lines drawn. Hierarchically, there is one thing that's missing, and that is the DS2246 at the top. So it did not get that. It did not describe the specifics of the switches. So it definitely was referencing cards to pull over here. And the switches did not have like cards for them to describe them. But wow, that was really good. Yeah, 2 R730XDs, 2 R930s, the Eaton 9PX11K unit, and the MSL 8096 LTO5 tape library, the DE6600, which, wow, just, I mean, it did an amazing job understanding a complex diagram. And I've fed these kind of diagrams before to like Gemma 3, 27B, and no, not this good. Definitely not this good. This is another level of good that we've got here. So this has gone pretty long. It's like 20 minutes here. So I'm going to just go ahead, cut this now, put together the guide. It'll be uploaded to digitalspaceport.com. It's like 4:30 p.m. So probably going to take me about an hour or two. By the time this video's out, hopefully I'll have that done. So there you have it. Qwen3 Omni, a killer local model. And I look forward to reading about what kind of stuff you're going to create with it. Be sure to check the channel history. Huge shout out to all of our channel members. Thank you very much for everything you do for the channel and all the people that buy me coffees. You fuel this madness. Literally, you feel this, this insanity that's going on in my garage as we achieve or attempt to achieve garage AGI. Everybody have a great rest of your day. Check you out next time.